Some rivers stand out not for their size, but for their remarkable colors, shades produced by minerals, plants, glaciers, or volcanoes. Today we're taking a look at 15 rivers whose colors are so unusual they barely seem real. Let's start with number 15, the Rio Celeste in Costa Rica. The Rio Celeste is known for its turquoise blue appearance. The river is located within a national park, which is a protected area that includes rainforests and mineral-rich waterways. This unusual color isn't caused by a dye, algae, or any artificial factor. Instead, it's produced through a well-documented process involving mineral particles and optical light scattering. For years, local communities had some folklore explanations, like the gods mixing celestial paint, but scientific research eventually provided some clarity. A detailed study by the University of Costa Rica found that the turquoise hue forms at a point where the two clear streams meet, the Rio Buenavista and the Quebrada Agria. The Quebrada Agria contains acidic water with dissolved aluminum and other volcanic-derived minerals. Rio Buenavista carries particles of aluminosilicates, which are very small mineral fragments that are created by volcanoes. When they mix, the pH of the combined water changes and causes the aluminosilicate particles to aggregate slightly into larger particles. The particles don't significantly change the water's clarity, instead they create this optical effect that makes it look opaque and blue. And of course, the park's management has strict rules regarding access for visitors, including designated trails and viewing platforms, both for safety and to protect the fragile mineral balance that creates the color. The river also has a well-known point called the Teñidero, which is where the streams visibly merge and the water abruptly changes to turquoise. This location is often photographed because the color shift is so dramatic. The waterfall along the river is another major highlight, and its pools display the same vivid blue due to the consistent minerals. But there's no known alternative causes, and no evidence suggests that this color comes from any biological pigments, pollution, or unusual activity. It is apparently entirely natural. Number 14, the Cano Cristales in Colombia. The Cano Cristales, we've talked about this one. It's widely known as the River of Five Colors because sections of it appear red, yellow, green, blue, and black certain times of the year. This unusual coloration is entirely natural, and it's caused by a single aquatic plant species, the Macarenia clavigera. This is not an algae, and it's not a coral-like organism. It is a flowering plant that grows only in a very specific condition. This coloration happens during the predictable seasonal window, typically from June to November, when water levels drop enough to allow sunlight to reach the plant beds. When the conditions are right, adequate light with stable water temperature and moderate flow, the plant turns a vibrant red. The red coloration comes from pigments produced by the plant, similar to pigments found in other aquatic vegetation and land plants. When combined with naturally yellow-tinted sands, green mosses, darky rock riverbeds, and clear water, the river appears multicolored. Now, Cano Cristales, unlike the previous entry, has almost no sediment load, which is unusual among these kinds of tropical rivers. The riverbed's composed primarily of quartzite sandstone from the ancient Guyana Shield Formation, which doesn't release any fine sediments easily. The water chemistry here is well documented and doesn't contain pollutants or unusual minerals. That plant species, though, Macarenia clavigera, requires very specific conditions: shallow, flowing water, direct sunlight, and a stable temperature. This coloration is therefore not seen year-round. Only during the rainy season, higher water levels will reduce the sunlight penetration and the colors will fade. But because Cano Cristales is situated in a national park, the ecosystem is monitored closely. Visitors are only allowed in designated areas, and regulations prohibit sunscreen when you go in there. The Colombian government, environmental scientists, and park managers have all emphasized the importance of preserving the river. The Colombian government, environmental scientists, and park managers have emphasized the importance of preserving the river's balance, as the plant responsible for these colors is sensitive to both physical disturbance and chemical exposure. Number 13, the Blackwater River. The Okefenokee Swamp, hey, that's down in southern Georgia and northern Florida. It's home to one of the most well-studied blackwater river systems. This swamp drains through two major blackwater rivers, the St. Mary's River and the Suwannee River. But the Suwannee's headwaters within Okefenokee are especially known for their dark tea-colored appearance. This unusual coloration is entirely natural. This dark color comes not from pollution, algae blooms, or oil. Instead, it's caused by dissolved organic compounds. When leaves, pine needles, peat, and other organic material decompose in this acidic, low-oxygen condition, they release compounds into the water, and the tannins in there absorb light in a way that produces this distinct reddish-brown or nearly black appearance, similar to brewed tea. It's making me thirsty. The Okefenokee swamp sits on a bed of peat, up to several meters thick in some areas, and rainwater's the primary source. Because the swamp lacks any significant mineral content from the underlying rock, the water remains soft and acidic. The ecology here of the river is adapted to those kinds of conditions. Many fish species, like bowfin, warmouth, and chain pickerel, thrive here in this water. Reptiles, including alligators, are common, and the swamp hosts large populations of amphibians and invertebrates. But the dark color can make visibility pretty poor. It's got no negative ecological effect, which is nice. Species that are native to the swamp do rely on senses other than sight, and the tannin-rich environment does support many food webs here. Heavy rains will dilute the tannin concentrations and lighten the water slightly, while drought does intensify the color. However, the color really never disappears completely. Scientists have taken water samples for decades here to analyze dissolved organic carbon, the pH, the sediment load, and flow rates, and the consensus is clear: the blackwater color is stable. The Okefenokee National Wildlife Refuge maintains large sections of the swamp, and river access is regulated. Canoeing, kayaking, they're all allowed in designated areas only, and the water quality is measured regularly. There is no scientific uncertainty about why the river is black. The Okefenokee's Blackwater River is one of the most distinctive naturally colored waterways in North America. Number 12. The Yellow River of Rio Tinto. Rio Tinto. It's located in southwestern Spain in the province of Huelva. It's one of the most scientifically studied colored rivers in the world. The river's name, which translates to Red River, comes from the iron-rich appearance, but in many stretches, especially where oxidation is strongest, the water displays a deep yellow color due to dissolved iron compounds. This unusual color is natural and it's well documented. The source of the river's color is the extremely high concentration of dissolved iron. This basin sits on one of the world's largest deposits of massive sulfide ore, which contains minerals like pyrite and other sulfide-bearing formations. When those minerals interact with oxygen and water, they undergo oxidation, releasing iron into the water, both ferrous and ferric forms. Ferrous iron can give the water a darker tint, but ferric iron, produced when ferrous iron further oxidizes, imparts a characteristic yellow. This is known as acid mine drainage when it happens near a mining activity, but in the case of Rio Tinto, the underlying geology naturally produces this acidic, metal-rich water. The river's pH is often also extremely low, sometimes near 2, which keeps the iron and other metals dissolved rather than precipitated, and that allows the river to maintain its color. But that yellow coloration is the strongest in areas where water flow is slower and oxidation's more complete, allowing the ferric iron to dominate. In some faster-moving sections, shades will shift towards red or orange due to the suspended iron, and during heavy rains it may temporarily dilute and lighten in color. And despite this harsh chemistry, it does support some stable ecosystems that are uniquely adapted. However, no fish or higher aquatic animals can survive in the most acidic stretches. Downstream, where the pH gradually rises and metals precipitate out, some ecosystems begin to reappear. But while mining in the region has amplified some of the processes of the river's extreme coloration, it is rooted in natural conditions that have existed for millions of years. Number 10. The Versasca River in Switzerland. The Versasca River in southern Switzerland. It's known for its exceptionally clear emerald green water. This striking color is due entirely to water purity, depth variation, and light interacting with the riverbed's granite formations. The coloration is natural and stable as it flows through Ticino, an alpine region with steep terrain and minimal soil erosion. The effect is similar to the coloration seen in some mountain lakes where clarity and reflective geology combine to create these vibrant hues. In some shallow areas of the rivers, the sunlight will reflect directly off the granite, which produces these bright golden-green tones. In the deeper pools, the water absorbs red wavelengths more strongly, allowing the green and blue to dominate, resulting in a deeper emerald appearance. There's no evidence of any algae or microbial pigments here. In fact, the water's too cold and fast-flowing for any sizable algal populations to develop. Ecological studies confirm that the rivers host typical alpine fish species too, like trout and grayling, but none of which affect the coloration. Divers have reported visibility extending up to 15 meters, which is unusually high for a river. and that kind of clarity allows the green to appear even more intense when viewed from above. Photographs often highlight the river's natural pools, some of which look artificially colored, even though the effect is entirely natural. The coloration seen today is the same observed historically too. It's supported by the geological stability of the area and, of course, the minimal human disturbance. There is no speculation on the Versasca River's color. In its explanation, its beauty comes from clear water, alpine light, and the rocks beneath it. Number 9. The Blue River of Hokkaido. Hokkaido, Japan, and the Blue River. It's more commonly recognized as the Biei River, flowing near the Shirogane Blue Pond. It is known for its bright blue coloration. It's not created by any artificial dyes either, or microorganisms. It's caused by a naturally occurring combination of mineral-rich water and fine sediment particles suspended in it. It runs through an area that's influenced by the volcanic activity of nearby Mount Tokachi. Hot springs, geothermal vents, and mineral-bearing groundwater contribute to this water chemistry, and one of the key components associated with it is aluminum hydroxide, which forms when mineral-rich water mixes with the river's water containing colloidal particles. Now, those particles scatter sunlight in a way that reflects predominantly blue wavelengths. The coloration is strongest near the Shirogane Blue Pond because the pond acts as a settling and mixing basin. The pond itself was created unintentionally in the 1980s when engineers built a dam to control mud flows after a major eruption. But although the pond is artificial, the coloration is entirely natural. Seasonal changes will influence the intensity but not the cause of the color, and during the winter when snowmelt is minimal, the blue tone can appear more concentrated. In spring, increased flow from melting snow can lighten the water's color somewhat, but the blue hue does persist. Heavy rainfall will temporarily reduce the blue appearance if the sediment from the surrounding slopes enters the river, but the clarity typically returns quickly. There's no unusual biological agents contributing to the color and no evidence of any chemical contamination. Fish species found in the river are typical for these cold, clear waterways in Hokkaido. And the Blue River has become an important reference point for Japan for understanding how geochemical factors can combine to create these distinctive natural water colorations. This vivid blue is not a rare or unstable phenomenon, but a consistent feature supported by clearly documented causes. Number 8. The Emerald River of Jiuzhaigou, China. The Jiuzhaigou Valley in Sichuan Province in China. It's known for a series of lakes and rivers that display unusually vivid colors, ranging from deep blue to emerald green. Among these waterways, the emerald-colored river segments that run between Norlang, Arrow Bamboo Lake, and several downstream pools are among the most widely studied. The emerald color results from the combination of extremely clear water and dissolved calcium carbonate, plus light reflecting off a travertine, which is a form of limestone deposit along the riverbed. The whole valley lies on a formation that's rich in carbonate rock, and over thousands of years, mineral-laden water has deposited the travertine terraces, dams, and pools throughout the valley. Those structures create shallow basins where the water slows, which allows the settlement to settle and clarity to increase. As the water flows through limestone-rich areas, the carbonate dissolves into the river, and when the concentration reaches a certain point, it can increase the water's optical purity by binding with suspended particles and causing them to settle. The result is a water with very low turbidity and a brilliance that makes even subtle color variations appear much more intense. The presence of some vegetation does contribute to the color, but only in certain areas and only in predictable, well-documented ways. In the shallow sections, patches of submerged plants can make the water appear slightly greener, but they don't generate the emerald colors themselves. The dominant factor is the light interacting with travertine, clear water, and dissolved carbonates. Seasonal factors, of course, influence the appearance, but not the underlying mechanism. During autumn, when the forest turns bright red and gold, the river's green appearance is even more striking due to the contrast with the surrounding plants. This whole valley is a UNESCO World Heritage Site, and the water quality is closely monitored. Reports consistently show that the river's unusual color results from mineral geology and water clarity, rather than from pollution or artificial additives. The emerald rivers of Jiuzhaigou remain one of the best studied examples of how this carbonate geology and low turbidity water created amazing natural coloration. Moving on to number 7, the Pink River in Senegal. Lake Retba, also called Lac Rose in Senegal, is world famous for its vivid pink coloration, and during periods when the lake's water flows or mixes into connected channels, the same pink hue can appear in the river waterways just outside the lake's main basin. The pink color is produced by a salt-loving microorganism. This thing produces carotenoid pigments, most notably beta-carotene, when exposed to high salinity in intense sunlight. These pigments are the same type found in carrots and some algae species. The salinity of Lake Retba is extremely high, comparable to and at times exceeding the Dead Sea. This environment is ideal for that microorganism, and when environmental factors align, strong sunlight, warmth, and low dilution from rainfall, these things produce large amounts of the beta-carotene. No synthetic dyes, minerals, or artificial pollutants contribute to that color. And because the basin's lake is shallow, the wind patterns and seasonal evaporation, it can concentrate the salt in specific areas, making the pink color more intense. The color may appear slightly lighter in moving water because the microorganisms disperse more widely, but the pink tint remains clearly visible. There is no scientific uncertainty about this cause. The lake and its outflowing channels are well studied, and the biological pigment explanation is fully supported by peer-reviewed research. Number 6. The Green Yellowstone River. The Yellowstone region has numerous rivers and streams influenced by geothermal springs, and specific places like the Yellowstone River, they display noticeably green-tinted water. This is not due to dyes or pollution. Instead, the color is produced by a combination of dissolved minerals, extremely clear water, and light interacting with the riverbed's mineral deposits, especially in areas downstream. It's not uniform along the entire river. It is limited to certain stretches, though. The primary factors behind it are silica-rich thermal waters and dissolved calcium carbonate. When hot spring water enters the river, it carries fine mineral particles, most notably silica, or opal A, and travertine-forming carbonates that remain suspended or settle in the riverbed. When the river water is clear, the light entering the water reflects off those pale deposits and creates the green-tinged appearance. Hydrologists have mapped the exact locations of this, and water samples taken in these areas show elevated levels of this dissolved silica, which can increase transparency by reducing suspended sediment, and clearer water enhances the effect. And unlike algae-driven green coloration seen in some rivers around the world, this one's influenced river sections isn't caused by any large-scale algal growth. Water temperatures here also remain too cold and flow too fast for any widespread algal blooms to even form. Seasonal factors, of course, play a role in color intensity. During the late summer and fall, when flows are slower and clearer, the green coloration is most visible. Rainstorms can introduce sediment too and mute the color for short periods, though as soon as the water clarity returns, those mineral-driven green hues become noticeable again. The geothermal influence, too, on the river is well documented by the USGS, the Geological Survey, and the Yellowstone National Park scientists who regularly measure the water chemistry and flow patterns. But no speculative or unverified explanations are needed here. This phenomenon is an interaction between the well-understood optical principle and documented mineral chemistry. Number 5. The Rio Negro. The Rio Negro is one of the major tributaries of the Amazon River. It is famous for its distinctly dark, almost black coloration. Despite the appearance, though, the water isn't dirty or polluted. In fact, Rio Negro is one of the chemically cleanest major rivers in the world. Its unusual color comes entirely from the dissolved organic compounds, primarily humic and fulvic acids, which originate in the decomposition of plant material. The basin is dominated by sandy, nutrient-poor soils and huge expanses of forest that shed enormous quantities of leaves, bark, and organic debris. When that plant material decays under these conditions, it releases tannins and other organic acids, and those compounds dissolve into the river and absorb wavelengths of light that give the water this characteristic dark brown to black color. Now, importantly, the river's color doesn't indicate turbidity. The Rio Negro is remarkably clear when measured by suspended sediment. Because of the lack of sediment and nutrients here, the river does support fewer phytoplankton species compared to other nutrient-rich whitewater rivers. However, numerous species have evolved to thrive in the conditions. The water here typically is a pH between 4 and 5, making it too acidic for many types of fish, common elsewhere in the Amazon. And this region, too, is known for its amazing animals, including iconic species of fish like the discus fish, the cardinal tetras, the freshwater stingrays, and, of course, the pink river dolphins. There is no scientific ambiguity about why the Rio Negro is black. The coloration results from the consistent release of dissolved organic acids and not contamination algae or minerals. Its appearance is a direct expression of the Amazon rainforest's organic cycles and the unique geology of South America. Number 4. The Whanganui River in New Zealand. The Whanganui, it's on the North Island in New Zealand, and it's known primarily for its historical significance, but certain stretches of the river periodically display an unusual milky turquoise color. This coloration is natural and happens when fine glacial or volcanic sediments, commonly referred to as rock flour, enter the river system and interact with sun. This effect has been documented by New Zealand's National Institute of Water and Atmospheric Research and other monitoring programs. When heavy rain, landslides, or erosion loosens fine particles, they do wash into the tributaries that feed the Whanganui, and because these sediments are extremely small, often microscopic, they remain suspended in the water for longer periods than settling quickly. The phenomenon's not constant. It depends on erosion events and rainfall intensity. During dry seasons, the river appears more typical for a forested, temperate river. The nature of the sediment depends on the part of the watershed involved. Some tributaries carry volcanic ash deposits left behind from historical eruptions. Others carry glacially influenced sediments from higher altitudes, although the Whanganui itself is not a glacial river. Regardless of the origin, the color effect is the same. Suspended particles scatter the light and create this turquoise tone. The color variations have known negative effects on the ecology here when happening naturally. The native fish species like longfin eel, shortfin eel, and various galaxid species are adapted to the river's behavior. These species tolerate the temporary turbidity as long as the sediment levels return to normal ranges. There is no speculation needed here explaining why the unusual color shifts happen. They're caused by well-understood optical interactions between sun and fine volcanic sediment. It makes it one of the clearest examples of natural color variation that's caused by these suspended mineral particles. Number 3. The chalk stream blue of the Test River. The River Test in Hampshire, England, is widely known as one of the most pristine chalk streams in the world. And although most rivers in the UK have brown or greenish tones due to sediment, algae, or tannins, the Test consistently appears pale blue to blue-green in its upper and middle reaches. That blue tint is caused by conditions beneath the river, particularly the presence of chalk that filter the water to exceptional clarity. Chalk streams are rare globally, with the majority found in southern England. Their defining feature is the bedrock, porous chalk composed of primarily calcium carbonate. When sunlight penetrates such clear water, it interacts with both the water molecules and the light-colored chalk and gravel riverbed. Blue wavelengths scatter more than other colors, which allows the water to appear bluish instead of the brown tones typically seen. And this clarity of the river also provides a great view of aquatic plants like the water crowfoot, which grow in dense underwater ribbons. When combined with refracted sunlight, the river often takes on a blue-green, almost luminous quality. Seasonal changes do affect the appearance of the river, of course, though not the underlying cause of its color. During winter, increased rainfall can introduce sediment and slightly reduce the clarity, which mutes the blue tone. But in summer, when the water levels drop and clarity increases further, the blue color becomes more noticeable. Conservation groups that monitor chalk streams regularly document any seasonal variation, and all data consistently attributes the river's coloration to this geological filtration system. The blue hue, it's simply the result of a clean, chalk-filtered water interacting with light and pale riverbed sediments. Number 2. The Orange River of Carhuaz, Peru. In the Ancash region of Peru, near the town of Carhuaz, certain rivers and tributaries flowing from the Cordillera Blanca display a pronounced orange coloration. This coloration is caused by iron-rich sediments transported from glacial meltwater zones and exposed mineral layers in the surrounding mountains. The Cordillera Blanca is the highest tropical mountain range in the world. It's composed of metamorphic rocks and mineralized zones containing iron sulfides. When the iron-rich water reaches oxygenated environments like open rivers, they undergo oxidation, and ferrous iron converts to ferric iron, creating iron oxide particles that appear orange. This is the same chemical process responsible for the rust-like color observed in iron-rich springs around the world. In the Carhuaz area, several river segments are known for that coloration, especially during peak meltwater season from October to April. The intensity of this color varies depending on the glacial melt volume, the rainfall patterns, and sediment load. During heavy melt, the river can appear vividly orange. During the dry season, the color lightens, of course, as the sediment levels decline. As the glaciers there retreat and shrink, newly exposed mineral layers are releasing more iron readily, enhancing this natural oxidation process. That orange coloration therefore appears more in locations today than it did decades ago, but the expansion is still directly tied to that natural process. No artificial dyes or contaminants are responsible for the phenomenon. Local communities, too, often refer to these rivers informally as Rio Naranja, the Orange River, and the coloration has been observed consistently over many years. Government monitoring programs have confirmed that the rivers are safe to approach and observe, though not always suitable for drinking without treatment due to the mineral content. Number 1. The boiling blue of the Blue Lagoon River in Iceland. Iceland's Blue Lagoon, it's world famous, but what many people don't realize is that its outflow stream, the small river that carries its excess water away, is one of the most unusually colored natural geothermal waterways on the planet. It's entirely natural, and it's caused by dissolved silica and suspended colloidal particles. The river's appearance is consistently an opaque, milky blue, similar to the color of diluted paint. The system that feeds the Blue Lagoon comes from a volcanic field where superheated groundwater circulates through porous lava rock. As the water moves through these formations, it dissolves concentrations of silica, as well as trace amounts of aluminum and other minerals. And when this hot, mineral-rich water rises and cools at the surface, the silica precipitates into microscopic particles. Because they're so small, those particles, on the scale of nanometers, they scatter the sunlight in a specific way that reflects predominantly blue wavelengths. The result is a beautiful milky blue color, which continues downstream into its river outflow. Temperature, of course, also plays a key role. The outflow river is warm throughout the year, much warmer than typical rivers here in Iceland, because it carries geothermal water that's been cooled but not fully mixed with ambient groundwater. The warmth influences how silica remains suspended. If the water cooled any further or mixed with significant sediment, the silica would settle and that distinctive color would fade. But instead, the river maintains a stable environment that supports this coloration. Seasonal weather here too can slightly alter the river's appearance, but the color rarely disappears. Heavy rainfall can dilute the silica. Periods of dry weather allow the silica levels to rise again, making the blue color more intense. And the river runs through dark volcanic landscapes, which visually amplify the blue contrast. This contrast is entirely natural and requires no enhancement. The surrounding terrain simply accentuates the color of the water. There's no speculation required to explain this one. The Blue Lagoon's river is blue because of the colloidal silica suspended in the geothermal water. It's one of the clearest and most consistent examples of a naturally colored river anywhere in the world.